Hey, welcome back to the Intro to Programming course, Intro to Programming with Rust. I'm Joe, and today we're gonna finish our deal calc. This program, we're gonna make it, so it actually works. And then we're gonna cover data types, and we're gonna just add a little bit of shadowing. We talked about shadowing last video. We're gonna talk about it a little more, not talk about it more really, but use it in our program. So this is just an interesting blog post I wanted to show you. It's from the Microsoft Security Response Center. They have a little blog, and it's called An Intern's Experience with Rust. It was just interesting. Some of the things that the intern said, if you look even at just the headings, like Rust helped me grasp concepts that I should have known when writing C++. And Rust really is good at that because the compiler just kind of communicates so well what it needs and what it wants. And it just makes things simpler. It's not just the compiler either. It's, there's a good community and there's a good book on Rust that just really it makes it a great systems level program to learn even for beginners. It's just a great language. So just wanted to show you that. You can read through this post if you want. You can pause your screen and grab that link if you want, or if you just Google An Intern's Experience with Rust, Microsoft Security Response Center, it'll come up there. So, all right, let's work on our deal calc. So basically what we're going to be doing is just adding some things that we talked about last week, some numeric operations and some more variables, and by combining those two things, we're going to come up with a working program here. So not something that just prints random stuff, but it's actually going to do some calculations for us that are handy. Let's see, what do we need here? So we have our discount percent. Let's just set that at 50% right now. We need a variable to hold the original price. So that's going to be like the original. So if something, the original price of the product, like $39.99 or something like that, we'll say the original price is $100 for now. That makes it easy to, actually let's make this 40. That'll be, so we know that once it calculates, if it's calculating correctly, then we'll get $60 as our new price. And speaking of new price, we will need a new price variable. Let's see. Got that. So let's get our calculation in here. So we can declare our new price variable, which is just creating it without giving it any value. We'll just do that. And then let's start our calculations here. So we need to do two kind of equations. The first thing we need to do is figure out how many dollars we need to subtract from the original price. We can do that, so we'll make a variable dollars off. And then we'll put our equation here. So it's going to hold the value of whatever our equation equates to. And to get the dollars off amount, we want our original price times our discount percent. And divided by 100, because that's going to put the decimal point in the correct spot, basically. So, let's do it without this first, and we'll show you what we get here. Dollars off. Okay, save that. Let me get to the right spot here. Okay, cargo run to run it. What do we got? Cannot infer type. Oh, can't tell the type. We don't need that for right now. Just comment it out. Let's try this again. And constant is never used. That's just a warning. And so it still calculates, gives us 4,000. So the original price is $100 times the discount percent, which is 40%. so 4 times 100 equals 4,000. So that's calculating accurately. But we want to figure out dollars. So to get that, we basically have to move the decimal to the left 2 places. So boop, boop. So, but to do that, all we have to do is divide by 100. So that's going to give us, if we have an original price of $100 and it's 40% off, then we're going to subtract $40. It's going to be $40 off from our original price. So let's try this again and make sure it gives us 40. Oh, what do we got here? Panic attempt to multiply with overflow. What do we do wrong? Let's see, dollars off. Divided by 100. This might need to be like a U32 or something. Let's try that. There we go. Okay, so it didn't like that. That was basically what was happening there. This was 8 bits, 100. So when you do an equation like this, every value in that equation has to be the same type. And when so basically Rust is going to have to say, okay, this is an 8-bit unsigned integer, this is an 8-bit unsigned integer, and this is an 8-bit unsigned integer. The highest number you can get with 8 bits is, if I'm remembering right, I think it's like 256 or 255. So when we multiply this by this, we get 4,000. That's a way bigger number than 255, so it doesn't fit. But it'll fit in unsigned 32 bits, because 32 bits is a lot more. That's like 4 times the amount. So it fits in that, and it calculates. All right, so that gets our dollars off, and then all we need to do is for our new price, and let's just make this that, and then new price, and we're going to have to do a little bit of manipulation with that new price variable, I think. But yeah, just original price minus what we just got there, dollars off. That's going to give us our new price after the 40% discount is applied, what it would, come out to. Let's see what we get here. I have a feeling the compiler is gonna give us some kind of an error here about this new price variable. We're gonna have to probably make that mutable, and we might even have to tell it the type also, which would be U32. But let's see. No, it worked. Okay. I was wrong. So, yeah, it inferred the type. Good. So $60 is our new price. And that makes sense, right? If you have a price of $100 and you get a 40% discount, then you're going to it's going to be $60. So, good. So now our program's calculating. We can say, like, let's say we have 50% off of $80. It should be $40, right? $40. There it is. So, and we'll add like a dollar sign and stuff like that. Actually, let's do that right now. So, we want to put it right there. Let's see. There, $40. That's just it's giving a dollar sign in that string, and then the new price goes right there. Now, we do have some limitations with this, and we're going to use data types to overcome them. So let's say our original price is not a rounded number, so it's like $39.99, like your typical price on stuff. Error. No implementation for float times integer. So Rust is trying to multiply float times an integer. Those are 2 different data types. Float is a floating point number. Floating point is any number with a decimal point. So like 32.2, 39, 399, 99, whatever. And an integer does not have a decimal. It's got to be a whole number. 4, 7, 5 billion, I don't know. Yeah, so you get the idea. So what it's trying to do is, since this is a floating point, that's a floating point, times discount percent, which is an integer, it can't do that. Those all have to be the same type, right? Everything in this equation has to be the same data type. So how can we fix that? Well, we can add just a decimal right there, and that makes those two work together, but then this is still. So let's just change this. We'll change that to a F32. So a 32-bit floating point. So and instead of U32, which is an integer, we change it to floating point type. Let's see if we get things rolling here. Expected. Okay, so it's saying it expected F32, and this is on our line here, but we gave it a round integer. So all we have to do is put a decimal there. Let's run it again here. All right, and we can fix the decimal stuff later, but it's calcing right anyways, because 50% off of $40 would be $20, so it makes sense that it's a little less, right? So that kind of gives you, shows you data types. A lot of people don't like data types, but, understanding that every one of these variables, every one of these values is a type of data, has, it's some type of data. And understanding that and understanding what type of data it is, it helps you make your code a lot more secure, a lot faster, a lot cleaner. It helps you know what it's going to end up doing, because if you don't know the data type for things, you can sometimes get code that does things you didn't expect it to do. Like sometimes I know like a big problem in JavaScript is you might have like a string, like my string plus, and let's say my string is like, it's a string that's 10, and then you have maybe like my other string, and if it was JavaScript and we were going by conventions, it would be more like this. And this isn't even the right syntax for JavaScript, but and then let's say this was like dollars or something like that. Now JavaScript could see this as a string, but it might also just decide, oh, that's a number. And then whenever you try to combine those two together, it would maybe try to add them instead of concatenate them, or so, it does weird things. So it's good to know the data type of what you're dealing with. And types, it's not that hard to understand once you get it, right? I mean, especially with Rust, you saw the compiler tells you exactly what data type it's looking for. So what our error was before, that was that whole, let's look at that again. No implementation for float times integer. So it tells us straight up, like, we cannot multiply a float times an integer, right? So we got to either make all of our numbers, or both of these values, integers, or both of them floats. And there, so now we know like what we're dealing with. We know what data type we need to have there. That makes it super simple, and it prevents a lot of bugs and stuff in the long run. So some of the different data types, we've already seen U32, which is unsigned integer. That means no decimal points. There's also like I32, which is a signed integer, which just means, it can have like a negative sign in front of it or a positive sign in front of it or whatever. So that's what that is. And then, you can have 8-bit, 16-bit, 32-bit, 64-bit, I think probably 128-bit, I'm not sure, but usually like 32-bit is going to work for you in most cases. It's a pretty big number that fits into 64 if you really are using big numbers, So you got integers, floating points. I'm not going to go through all the different data types just because there are a bunch of them, and that's one of those things that you end up, maybe you see an error and you say, oh, a float, okay, what's a float? And you just Google it. You go to, you search, you find data types. Here's the integer types. There's the signed and the unsigned. Okay, let's keep scrolling through. What do we got here? Those are just, floating points. And then we got compound types, and we'll talk about those in a second. But some other data types in Rust, there are characters and there are strings. A character is just simple. It's like a number or a letter. A, B, D, just one. If you have like a string of those, then you have a string. And so that could be like A, B, D, or it could be like a word like Bob's Burgers. I don't know. I don't know why that just popped in my head. That's a good show though. It can be, a sentence. A string can be super long, so it can be a lot of stuff. Strings are really useful. You'll use them a lot in your programming. So dealing with types, it's maybe a little extra work, and we can annotate all these types. We can say, what were these? We'll just say F64. You can tell Rust explicitly, this is F64, so when it guesses, it's not going to guess wrong. You know exactly what it's going to assign to that value, to that variable, and that should work here. Yeah, so you can give it explicitly, or with constants, you have to give it explicitly. With variables, you don't. You can just let it guess. Not all languages even require any kind of typing. A lot of languages you just don't even think about types, and I personally don't like that. And it depends. What you're doing. If you're just making like front ends of web pages, it probably doesn't matter so much. With like just some simple JavaScript stuff. When you're doing like systems level stuff, you want a pretty deep level of control over your stuff, so that you prevent bugs and keep things secure and fast. So it can be a little extra work, but in the long run, I'm pretty sure it pays off. So there's also, with programming languages, some languages could even change the data type while it's running. So like JavaScript, and that's called dynamically typed. So it can actually change, like, it could say like original price is U32, and then it tries to multiply that by floating point value, and it's like, oh, I can't multiply those, so then it goes back and it changes this to floating point. So it changes it on you, and you would have no idea that it changed because it's doing it while the program's running. So some languages do that. Those are dynamically typed. Rust is what's called statically typed, where once you set a type on something, you got to go, you got to work pretty hard to change that type. You got to do some shadowing, or, you got to really explicitly say to the compiler, hey, I want to change this. And then when you do change it, once you've compiled the program, when that program's running, it won't change types, which, once again, depending on your use case, that can be extremely good. It can prevent some serious issues. Okay, so I want to show you just a little tip, and this will probably come in handy for you at some point. I'm like 90% sure. If you're doing some pretty good programming in Rust, at some point you're going to come across a time when you have a value and you're like, what is the type of that value? You don't know. You're like, original price. What data type is that? It's not written, anywhere in the code. So you want to what is the compiler deciding that is? Is it thinking it's F64? Is it thinking it's F32? Is it thinking it's a integer? Well, we can see it's probably not thinking it's an integer, since it's got a decimal point in there. But what size floating point maybe is it? So this is just a little trick. You can just put anywhere in your code. You can put let parentheses equal, and then put your variable name, say original price. And this will cause an error on the compiler, and that error tells you what type it thinks this is, what type it sees this variable as. So we can see it sees this as F64. So now we know That's what that is. That's F64, just like we had told it before. So it's a handy little thing to keep in your toolbox there. Types. So there's two different kind of categories of data types in Rust. Scalar types and compound types. Scalar are like the integer types, the floating point types. Compound types, there are some other types we have here. Arrays and tuples are the two main ones in Rust. And those are types that have more than one single value. So all the scalar types, that has one value, has one number, one number with a decimal, one whatever, maybe one character, whatever it is, it just has one value. Compound types can have multiple values. So an array in Rust would be something like 3, 2, 10, 40. So see how we have multiple values here, not just one value? So, and then the difference between arrays and tuples, an array, all the values in the collection of values have to be the same type. Whereas in tuples, they can be multiple different types. So like in a tuple, you could have blue, 32, orange, 99.999, Z, something like that. You can just have all different kinds of values in there. So those are the two main compound types that you're going to see in Rust. Basically, compound types are, just think of it as a collection of values all combined into one variable. You can actually, you can say, well, let's make our discount percent an array. So you're going to typically see, you're not going to see like 14% off. You're going to see like 10% off, 20% off, 30% off, maybe 40% off, 50% off, sometimes 60% off, maybe 75% off. So let's just use those. Oh, and we need our decimal in there, so they're floats. All right. So now we have a collection of values that are all stored in this one variable. And then to access just one value in that collection, we come down here and we use what's called an index. So every array has an index, and the index always starts with 0. The first value is always 0, and it counts up from there. So the first value is 0, 1, 2, 3, 4, 5, 6. So whatever value you want to access, you use that index. So let's get 50% off. So we're going to go 0, 1, 2, 3, 4 is how we get the 50%. So we just put a 4 in there. So we should get $39.99 with 50% off. It should be like that $19.99 or whatever. $19.995, whatever. Okay, what do we get? Oops, let me take my little note out of there. There it is. So, yep. Let's try 10% off. That's just going to be a 0. Index is 0. So 10% off would be like 40. It'd be like $4 off. So like $36-ish. $35.99. So that's an array. Tuple, we don't really have a good use for a tuple in this program. So, but tuple, would just be multiple values. There are uses for them in bigger programs. You'll come across it, and you'll know when you need it. You'll think like, I need to put multiple values in this one variable, and they can't all be the same type. Well, tuple will solve the problem. And as you notice here, the compiler detected that the type was an array. We didn't have to specifically tell it anything. That's not even how you, can't remember what you say for an array. Let's see. Array. Oh yeah. So if you're gonna type annotate an array, you put the type, and then you put the number of indexes basically. So we would put F64, and we got 1, 2, 3, 4, 5, 6, 7. So let's see if that works. Oops. Yeah, that works. So that's how you annotate an array. So that's pretty much it for types. Just remember, every variable in Rust, every value in Rust, every bit of data in Rust and in pretty much any programming has a data type. It has a type. This is a floating point. This would be a string of characters. So just everything in Rust has a data type. Okay, so let's do some shadowing just to kind of reduce our code down a little bit. Instead of having two prices, new price and original price, we can just shadow our price variable. So let's just delete this completely. Change that original price just to price. So the original price is $39.99. Then we can just shadow it. We can just say let price. Why is this indented? And then we're just going to put price. And so that should work. So it's going to get, oops, wait, one more. Oh, no, wait, another one. Okay. So now it's going to, let's see, we got price $39.99. So it's going to do $39.99 times 10 divided by 100. All right. So I just put some code in here just to do a little test. What we're going to do is we're going to see the value of price here before we change it, and then here after we change it with our shadowing, and we'll get the price again. So first it's $39.99, which is what we set it to up here. Then after we shadowed it and gave it its new value, it became $35.99. And we just used one variable, but we were able to assign two different values to it by shadowing. So I thought that was a pretty good example of shadowing, and we'll actually leave that in there just because it does make our code a little bit more concise, and conciseness is usually a good thing with code. So one thing to remember with shadowing is don't forget the let. If we don't put let in there, it's going to tell us to make our variable mutable. It cannot assign twice to an immutable variable. So we could also make this mutable. I think that'll work. Let's see. Actually, I don't think it will. Yeah, it'll work. So we can do that too. But in this case, since we're using price over here too, it's just probably more conventionally accurate to use shadowing instead. So, but yeah, so we covered data types and we improved our code a little bit with shadowing. We got everything working, right? So we got a functioning program here now, which is great. I heard a quote the other day, actually. It was something along the lines of like, your program is never less than 90% complete and never more than 95% complete or something. Which basically is so true, because you always have this core functionality that, it's pretty simple and pretty quick to get finished once you have that core kind of algorithm like this part right here. But then you can just keep adding feature upon feature upon feature and just, keep tweaking things, making things better. Like we're going to do here throughout the rest of these videos. We're just going to keep making this better and better, cooler and cooler, adding things. And so, you're always 90%, never less than 90%, and never more than 95% done with a program. So I just, one thing I want to just ask you guys, just this kind of a little discussion point. Do you think you're the type of person that would rather let the compiler guess the data type So instead of, explicitly stating it, would you rather just not bother with doing that and just let the compiler guess it for you, like we're doing here? Or are you the kind of person that you want to know exactly what value is being assigned? Don't let the compiler guess. You don't like the computer guessing. You want it, to be explicitly written, even if that means you have to, write a few extra characters in there. Take a little bit more time to make sure you figure out what the value is, what the data type is. So, and then you can comment that below if you want. Just curious, like if you see any advantages and disadvantages with each method. One advantage of explicitly giving the type is that you know what it is. You're never letting a computer that may not be thinking the same way as you, I guess, guess what you're thinking, basically. So but what do you think? Let me know. In the next video, we're going to cover functions, which is definitely one of my favorite parts of programming. Functions are awesome. I love them. And then we're going to quickly cover statements versus expressions. We'll go through our code and just talk about which parts of our code is a statement, which part's an expression. And then we'll cover comments, which is just another quick little thing. But functions will be the main thing in the next video. So I'm looking forward to that and hope you stick with me. Thanks for watching.